let's take a look at our next category, our next topic that deals with scientific variables. A variable is something that can be changed within an experiment. So there are different types of variables. We want to break those down a little bit. Control variables are the parts of the experiment that scientists will keep the same. Scientists will conduct experiments to understand the relationships between the variables. So you want to make sure that you have control variables. Like if everything changes, there's no way to make effective conclusions. So you always want to ask yourself, what is the same between the groups or the studies or the different experiments? That's going to be the control variables. So why do scientists need to think about control variables in their experimental designs? Controls will give the baselines. So if you have baselines, you're able to make comparisons more effectively and develop stronger conclusions. Now, independent variables are the factors that are intentionally changed during an experiment. And for a really well-designed experiment, there should never be more than one independent variable per hypothesis. So if you have a hypothesis, oh, I think this is what's going to happen, change one variable to see if that hypothesis is true. Now, when you're trying to identify an independent variable, ask yourself, what's the purpose of the experiment? What's the x-axis of the graph or the first column of any table? Whereas a dependent variable is what changed because of the change in the independent variable. For example, if a scientist increased the temperature, then the color of the liquid became darker. The temperature change would be the independent variable. That's the thing that the scientist changed intentionally. The color of the liquid would be the dependent variable. That's the thing that changed because of the independent variable change. So experiments can have one or more dependent variables. So for instance, if you change the temperature, maybe a lot of different things are going to happen, right? So it is possible to have more than one dependent variable. So when you're trying to identify what the dependent variable is for an experiment, ask yourself, and what happens when the scientists change the independent variable? And what is the y-axis on the graph or the other columns of any tables? That information is going to indicate the dependent variable. All right, so let's take a look at an example of a passage here. Okay, so we'll go through this together and break this down. We have an office manager here noticing each time she touches the metal filing cabinet next to her desk, she experienced an electrostatic shock, commonly known as static electricity. Her assistant only rarely experienced such shocks when touching the cabinet. The office manager wondered why this might be. So already we're seeing that initial phenomenon, right, about static electricity, and the office manager is wondering, why is it that when the office manager touches the cabinet, she experiences shock, but the assistant does not? So we've seen that first paragraph, a phenomenon and a question. The question is, why am I getting shocked as opposed to the assistant getting shocked? So in the second paragraph, we see in that very first line in the second paragraph, says the office manager developed a hypothesis. So there's our hypothesis. Perhaps differences in clothing could explain why she was experiencing more shocks than her assistant. So notice here, it's our educated guess that the office manager is making. The educated guess is, oh, it's the type of clothing that's causing more shocks. The office manager liked to wear nylon clothing, and her assistant usually wore other types of clothing. So different clothing might account for the different number of shocks. So her assistant usually wore cotton clothing. So now we see the next part here. We're going to test the hypothesis. The office manager convinced her assistant to wear nylon clothing to work every day for a week, while she herself wore cotton clothing. So we're seeing already the experiment happening here, right? How's this experiment happening? 1 week, the office manager is convincing her assistant to wear nylon. She herself is wearing cotton. Then next week, they switch. Then after that, to control for the possibility that the differences in shocks were due to differences in their footwear, they wore identical shoes every day. Notice how the identical shoes, that's going to be our control factor, right? That's the thing that's not going to change. So if we break this down, the independent variable is going to be the different material, nylon versus cotton. The control is going to be the keeping the same type of shoes. They wore identical shoes each day. During the experiment, both the office manager and her assistant recorded the number of times they experienced shock. So then that is going to be our data, right? So just simply recording the number of times they got shocked is going to be the data. And they also record the number of times they experienced electrostatic shocks when doing so. So the number of times they touched the filing cabinet and the number of shocks that they received. So notice here, our dependent variable, what's going to change because of the different types of clothing? The number of shocks, how often they get shocked. So then from there, we see the results of this experiment. At the end of the first week, they found the assistant had experienced 73 electrostatic shocks, while the office manager experienced 10. During the second week, the office manager experienced 68 shocks and her assistant 12. So notice, wait a minute, what's going on here? That first week, the assistant got shocked more. During the second week, the office manager got shocked more. And notice that difference is huge, right? A lot more. 73 versus 10, 68 versus 12. So we see here our results from this experiment. And from those results, we see the conclusion. The manager concluded that these results supported her hypothesis, and as a result, she decided to switch to mostly cotton clothing. So this is our experiment, using the scientific method to create an experiment. Now let's take a look at a couple of questions that follow from this. Again, you can use our summaries that we've come up with from this passage to try question number 5. Pause the video, give yourself a minute to try this one on your own, and when you have an answer, unpause the video, and we'll go over this one together. All right, number 5 says, which piece of evidence from the passage supports the theory that differences in clothing were causing the shocks? Which piece of evidence is actually giving that? Well, notice, what's the evidence that's supporting the theory different clothing causing shocks? Well, what evidence was there to show that, oh, it must be the clothing? Well, when a certain type of clothing was worn, they experienced a different number of shocks, right? So basically, we're looking here at what happened during the experiments, right? When the assistant wore nylon, she got shocked more often than when the manager was wearing cotton. Which answer choice matches that? That's going to be answer choice A. When the assistant wore nylon, she experienced more shocks than the manager did while wearing cotton.